Hello everyone, this is a discussion on units and unit conversion. And the first thing I want to discuss, of course, are parameters, so then we can actually discuss the units of these parameters. Now the main ones we really want to focus on are length and time. We'll kind of see that all of these, with the exception of mass and weight, actually are composed of those. So let's just take a look at some particular units that we know from everyday use in life, basically. For length, you may think of inches, feet, yards. In the metric system, they have centimeters, meters, there's decimeters, kilometers. If you want to get kind of, maybe not technical, but if you kind of want to get into the weird, obscure units of length, there's furlongs. There are all sorts of weird, wacky ones as well, so I'll just put ... etc. Time also, well, I don't want to say also, but time actually only has a few that are not obscure, of course. So that's, of course, just seconds, minutes, hours, and then if you want, you can get into days, years, weeks, so on. Now, what would be a kind of weird unit of time? I don't know, maybe something like light year is a good one. Of course, you can get into milliseconds if you like. A moment, that's a kind of interesting one. Moment is a medieval measurement of time that isn't really known as of right now because not much was recorded back then. But I believe it's a few seconds. It's the amount of time it takes to perform some task. In fact, that's usually where the tradition of these things come from. But these are just examples of different units, and they're all somewhat related in the sense that they all correspond to the same parameter. In other words, there is a relationship between the number of inches in a certain length and the number of, let's say, kilometers in a certain length. And that's what we're going to be discussing when it comes to unit conversion. But for right now, let me just kind of talk a little more about this list. Now, I say mass/weight. They're actually different, technically. We'll talk about that later on in the class, as it turns out. But a unit of mass would be like grams, kilograms, grams. I think there is, forget if slug, I think slug is weight, but there's different ones so these are mass. That's all I'm going to say for mass. I guess milligrams is one. But again, that's in the metric system. Weight would be pounds. I guess ton. A ton would be a weight. Tons. Tons gets kind of weird because there's different types of tons. There is there's like there's the empirical ton, and then there is, I guess it would be like the European ton. I forget exactly what it's called. But there's actually different versions of them. So units can be a little weird when it comes to these. But that's all I'm going to say as far as that goes. And again, there are mass and weight, and they are technically different. And the difference really, again, we'll see more later on in the class, but mass is a very universal concept. So no matter where you are in the universe, no matter what planet you're on, your mass will always be the same. But if, let's say, you're on the moon compared to the Earth, your weight will be different because you're lighter corresponding to the gravity on the moon. Let's say if you're on the moon. So there's a difference there. Your mass will still be the same, but your weight depends on the gravity of the planet you're on. So again, it's a little technical, but we'll see that in a later lecture video. Velocity and speed also are kind of different. But here I can kind of say that velocity really is just speed, but with a direction. So velocity could be negative or positive, but speed is just the absolute value of that value. But as far as unit goes, they have the same unit. And the unit would be something like, think of miles per hour, is the one most people think of. Or if you think of something in the, let's say, metric system, then it's kilometers per hour. You could also have meters per second. You can have inches per, I don't know, inches per minute, for instance, or feet per minute. Just kind of goes to show that in reality, this is just composed of length and time. Just take your favorite length unit, divide it by your favorite time unit, and there you go. You have a unit for velocity or speed. Now, area is also one that's kind of corresponding to length, because area is just a length unit multiplied by a length unit. The one I kind of think of more commonly would be like inches squared, feet squared, miles squared. I guess mile could have been a length unit. I guess it could be kind of weird. It could be like inch times centimeter. But again, it's just multiplying two length units. And volume, well, volume, much like for areas, would be multiplying length units, but it'd be 3 of them because in volume, well, that's a 3-dimensional measurement. So here you can think of like inches cubed. How about, I guess you could do miles cubed, kilometers cubed, something like that. You can even do liters. Liters is another measurement of volume. Milliliters. As it turns out, there's a relationship between liters and centimeters cubed that we'll again discuss a little later. But anyways, I just kind of right now wanted to show you a rundown of examples of units with different parameters in mind. But the ones we really want to focus on again are length and time for right now. So now we're going to discuss on how we can convert different types of units within a given parameter. Right, so now in our discussion for conversions between units, I first mainly want to talk about lengths, but the metric system kind of corresponds to anything, really anything. I mean, to be quite honest, metric system is even used when it comes to digital units. If you think of digital storage, like think of megabytes, gigabytes, those are all something I'm going to be discussing here, even though they're not really, I guess kilobytes would be this K, but we'll kind of see how to handle metric conversions based on this. But again, that goes a little beyond lengths. You can even get that involved into time, if you ever heard of milliseconds, I think I mentioned previously. But mainly I want to discuss lengths here. So, of course, the way the metric system works is you multiply by 10 to get each of these prefixes. So there's multiplying by 10 to go from left to right, and there's dividing by 10 to go from right to left. So you divide by 10, divide by 10, divide by 10. So as a little bit of an example here, but by the way, there are a few prefixes I didn't list here. To be quite honest, the ones beyond this, you don't jump by 10, but you jump by 3 tens, so you jump by 1,000. So in fact, to go from here to here, you would multiply by 3 tens, so that's 10 to the third, which is 1,000. And then if you go this way to get to milli, you would divide by that. So in fact, you'd multiply by 10 to the negative 3. If you remember that negative powers just means dividing, basically. So if you were to jump a few more out here, so let's just say, imagine this is going back a few more, some more spaces here. So if you jump another times 10 to the third, another 1,000, you get to mega. Think of megabyte. And then here you would get to giga. Think of gigabyte. The next one would be tera, like terabyte. So those are mainly used in, I guess, like digital storage, but you could use that in anything that uses the metric system. So for instance, we'll be taking a look at that in this example involving meters. So this question mark, by the way, would be whatever our base unit is. So in this case, our base unit will be meters, but in the digital storage, the base unit will be byte or bit. So for 1 kilometer to meters, well, again, if our base unit is here, we have to multiply by 1,000 to catch up with that many kilometers. So there's 1,000 meters in 1 kilometer, which sounds a little funny because you think, okay, meters is the smaller unit and kilometers is the bigger unit, but why does kilometers have a smaller number? And it's because you need that many small units to make that big unit. So the big units will generally have smaller numbers in front of them. So centimeters, well, there's 1,000 centimeters in 1 meter, so this is 1,000 times 1,000, which is actually 6 zeros. So this is really 10 to the 6 centimeters, but I'll write it as actually writing out 6 zeros. So it's 1 million centimeters in 1 kilometer. And gigameter, well, this is kind of funny because we kind of had to go backwards to go from gigameter to kilometer. So there's actually 0.000, I guess there's 5 zeros, 1 gigameter in 1 kilometer. Now, why is that the case? As it turns out, this is 10 to the negative 6. So this is good to go over because it's kind of like scientific notation a little bit. So 10 to the negative 6 means you grab this 1 right here. Well, I guess you start here. Let's think of it like this. It's 1 times 10 to the negative 6. So you start with 1. So you start with the decimal behind the 1. And then you move the decimal to the left 6 times. If it was positive 6, then you move the decimal to the right 6 times. So that's why 10 to the 6 has 6 zeros behind it, but 10 to the negative 6 only has 5 zeros, because one jump will get you past the first one. And then 2, 3, 4, 5. So notice there are 5 gaps here. Sorry, 6, there we go. So to get to 6 spaces to the left of 1, you'll have 5 gaps after the 1, so you'll end up with 0.000001, so 5 zeros. Okay, now of course gigameters we won't really be dealing with too much. This is a little technical, but at least gives us an idea of not only scientific notation, but how to handle the metric system a little bit. Now the imperial system is a little more straightforward, but there's not really too much going on. There's only like 4 pieces here really. So we have inches, feet, miles, and I guess yard would be in between. So here I'm giving you a specific conversion table to go by basically. Here this is more like you kind of have to think about it, but it's a universal type of deal. But this is very, very specific. So there are 3 conversions I'm giving you. 12 inches is 1 foot, 5,280 feet are in 1 mile, and 3 feet are in 1 yard. Great. So let's see. So for this example, we want to find out 51 feet is how many yards and how many inches. Well, one way to do this, honestly, is just to look at the conversions involving feet and yard and feet and inches and multiplying both sides by whatever we need to make 51 feet. So if you think of from feet to, let's do feet to inches first. So let's grab this equation involving feet and inches. So it's 1 foot. And I'm going to multiply both sides by whatever we need to make that 1 foot 51 feet. And of course it's just 51. So if you multiply both sides by 51, then you'll get however many inches are in 51 feet, and then you just use your calculator from here. I'm going to attempt to do this in my head. Let's see. So 12 times 50 is 600, plus 12, that's 612. So there's 612, that's inches. Excuse me. There we go. 612 inches in 51 feet. Good. And now for yards, it's a very similar idea, but it's a little different. So if you think here, we have our equation. So that was this equation, now we have this equation. We have 3 feet and 1 yard. But now this is kind of harder to do because we have to ask ourselves, what do we multiply 3 by to get 51? So really what we're doing is we're dividing. In fact, one way to handle this is you can divide both sides by 3, then multiply both sides by 51. Now, I know that 51 divided by 3 will actually give us 17. Yeah, because 7 times 3 is 21. So adding 30 to that will give you 51. So yeah, so 3 times 17 is 51. So if you multiply both sides by 17, that'll actually do the trick here. And that'll give us 51 feet is equal to 17 yards. Which I know seems like the 17 kind of came out of nowhere. But I'm going to actually show you a little bit of a trick right now, in fact. I'm going to kind of skip the conversions for time because those are very, very simple. To be quite honest, everyone really knows those. There's 60 seconds in a minute, there's 60 minutes in an hour, and that's basically, I mean, if you want to go beyond that, there's 24 hours in a day, 7 days in a week, and then 52 weeks in a year. 365 days in a year. But anyways, I'm going to erase this and now we're going to do some more examples. But I want to show you this kind of trick, and it's called a conversion table. So we're going to see how we can use a conversion table to better handle these conversions, because doing it this way, though it's doable, it makes you itch your head a little bit. And to be quite honest, the conversion table takes away that confusion factor. All right, so here I've listed out a few of the conversions we just discussed. So there are lengths here, we have imperial, metric, and then here we have the time units I kind of discussed but didn't write down. So I feel we deserve to at least see them written down somewhat. And we're going to use them in finding these conversions. Time we won't really do right now, but we'll kind of keep this and we'll get time involved later on. So again, I just want to mainly show us the conversion table right now. So the way conversion tables work is you make a horizontal table like this. So we have 2 rows. We're going to start with the unit we want, well, the unit we have given, we have a number given, so we know there's 51 feet, so let me just write that above like this, and what we're going to do is we're going to cancel out feet, and then get the next unit in line. Now sometimes it takes multiple steps, so this can be as long as you want it to be, but right now I think this is just going to be a one-step thing. So we want to cancel feet, so I'm going to put feet below, and then what we want to turn this unit into is yards. So in a perfect world we can go from feet to yards, and in this case we have a conversion between feet and yards. We don't have to do multiple steps. So we know there's 3 feet in 1 yard, so I'll do it like this. 3 feet is equal to 1 yard. And basically what this is allowing us to do is saying that since 3 feet is equal to 1 yard, if you divide both sides by 3 feet, you get that the number 1 is 1 yard divided by 3 feet. And then multiplying that, which is just 1, you can multiply 1 by anything, you get the same number. You'll get this, but now in yards because the feet will cancel, which is a different way of seeing the previous equation way I showed you, which still works. So here the feet cancel, and 51 over 3 actually reduces. So this really is 51 over 3, but 51 over 3 is 17 using your calculator, or if you know how to do that in your head, that's fine. So the answer is 17 yards. Great. So again, it wasn't super crazy. This one will be a little crazy. Now the only conversion I didn't show you previously that's written down here is this one. This is the very, very accurate conversion that actually links metric to imperial length conversions. So this says 2.54 centimeters is equal to 1 inch, and this is supposedly pretty accurate. In fact, I think this is the most accurate link between the two types of units. So we're going to ask ourselves, how many kilometers are in 1 mile? Now, if it's less than 1, then that means there's more. If it's less than 1, then that means there's more kilometers than there are miles. So you can actually fit more mile into 1 kilometer. But anyways, we'll see that as we go along. So we're going to start with 1 kilometer in our conversion table. And I want to, again, in a perfect world, if we had a conversion from kilometer to mile, we'd be done. But we don't. The only part that I see that involves mile is this, that involves feet, but then our only link between metric to imperial is centimeters to inches. So that means I need to convert this to centimeters, get that to inches, and then swing inches all the way back to miles, which is going to be a little long, so just kind of bear with me and let's see if we can do it. So I know 1 kilometer right here is 1,000 meters. So I want to get rid of kilometers, so I'm going to divide by kilometers and multiply by what it's equal to in our conversion, which is meters. And there's 1,000 meters in 1 kilometer. So notice here the kilometers will cancel, so now we're in meters. Great. Well, we want to get into centimeters in order to convert to imperial. So now we're going to use the one that involves centimeters and meters, which is this one. There are 100 centimeters in 1 meter. So again, I want to cancel meters and now introduce centimeters. And there are 100 centimeters in 1 meter. These are canceled. Great. And now centimeters to inch finally. And according to our conversion, there's 2.54 centimeters in 1 inch. So I know to place the numbers like that. And then inches to miles isn't too bad. We need to jump through feet first. So to get rid of inches and to now introduce feet, in 1 foot there's 12 inches. And then finally, the inches cancel, we're in feet. And now finally, to get from feet to miles, there's 5,280 feet, just like that, in 1 mile. And the feet cancel. Perfect. So now what we're going to do is we're going to treat this as a big fraction, but the unit will definitely be in miles now. So basically we're going to divide everything on the bottom. So multiply everything on top, and then divide everything on the bottom. So I'm going to use my calculator to do this. So I'm going to write 1,000 times 100 and then divide by 2.54, divide by 12, divide by 5,280. Let's see what we get. All right, so my calculator actually got 0.621 miles, rounded to 3 decimal places. And this tells us that miles is actually the larger unit because it has the smaller number in front of it, if you remember our discussion on that. Now, at the same time, if you divide both sides by this number, by 0.621, what you end up getting is that 1 mile is 1.609 kilometers. So we now have these two new unit conversions The answer to the example, of course, was just 0.621 miles. But now we have these two new unit conversions. If you wanted to, you can add them to our list of conversions. And now we know exactly how many miles are in a kilometer, so we don't have to run through this argument each time. All right, so now we're going to do something involving time. And then I also want to do one involving area to finish out the video. Right, so hopefully we have enough space to handle all these in one board here. But I want to convert 60 miles per hour to kilometers per hour. Then I want to convert it to what's called SI, which is standard international units, which I'll talk about shortly. And then 100 square feet, this is the area problem I was talking about, into square yards. So let's see if we can handle doing this. So I'll of course start off with the table, but we have to be a little careful. So as it turns out, miles per hour, as we spoke of previously, is composed of two units, miles and hours. So I'm going to write this as 60 miles divided by 1 hour. That's of course what it means to have miles per hour. It means for every hour you've achieved 60 miles. So it's really division. So what I want to do is I want to keep hours actually, because notice this is still over hours, but now I want to convert miles into kilometers. And we actually have that unit conversion. I didn't write it here, but we just did that in the previous example. In fact, we had two of them. So we want to get rid of miles and now get kilometers. And the one that I remember was that, I guess the one we did first, which is 0.621 miles in 1 kilometer. Equivalently, you can write 1 mile in 1.609 kilometers. That was the other result we got. So now let's use our calculator here. And there's not really too much. This is just one-step conversion. Because now our unit is kilometers over hours, which is exactly what we were looking for. Right, so my calculator gave me 96.6. So it's about 96.6 kilometers per hour. And in fact, you know what? I actually knew this off the top of my head. And I'll tell you why. If you're ever into cars and their speed, they're always measured by how fast they can achieve a 0 to 60. But in metric, they actually go from 0 to 97 because they're dealing with kilometers per hour as their standard for car speed, basically. So I knew that 60 corresponds to 97. And this is about 97 if you round to the nearest integer. Anyways, now converting 60 miles per hour into SI. What is SI? What is standard international units? What's that all about? Well, as it turns out, for length, the standard length unit is meters. And for time, the standard time unit is seconds. Or just S. S for seconds. So miles per hour in standard international units would be meters per second, actually. Not even kilometers per hour. So it's in meters per second. So these are going to be the standards we'll be going by basically throughout the class, unless otherwise instructed, depending on the question. So we're going to very often be using these. In fact, for mass and weight, I'll just write it out here. The SI unit for mass is actually kilograms. I mentioned slug. Slug is actually a measurement of mass, but it's imperial measurement of mass. So notice these are really metric units. Anyways, so let's start our conversion. We have 60 miles per hour. We know what that's all about. That's 60 miles over 1 hour. And we want to get rid of miles. And we want to turn it into meters. Now we know into kilometers, so maybe we can just run that argument the same. So to convert miles into kilometers, that's fine. But now we want to get rid of kilometers and now introduce meters. So miles cancel and the kilometers will cancel. But notice there is how many meters in 1 kilometer? There's 1,000 meters in 1 kilometer. Perfect. And now we're done with the length unit. So now we're in, if you think about it, we're in meters per hour. We want to be in meters per second. So now I want to convert this hour unit, this time unit, hours, into seconds. So I need a little bit of space here, so let me erase what I've listed as being our SI units for length, time, and mass, respectively. So hours, so we're done with meters, so I'm not going to cancel that, but I want to cancel hours. So I want to get rid of hours, and I want to introduce seconds eventually. But I don't have a conversion for hours to seconds. If you want, you can just multiply 60 by 60 and you'll get to 3,600 seconds are in 1 hour. What I'm going to do is step by step to be more detailed. So I'm going to pass through minutes first. so that the hours cancel. Notice this has to be on top to cancel because it's on the opposite side of the fraction. There's 60 minutes in 1 hour like this. And then finally converting minutes to seconds. There is 60 seconds in 1 minute. And notice 6760 on the bottom is 3600. So we really could have said that there's 3,600 seconds in 1 hour, but I wanted to be a little more detailed about it. And here the minutes cancel. So the only unit we have left on top is meters, and the only unit we have on the bottom is seconds. So this will indeed give us a conversion from 60 miles per hour to something meters per second. So now it's calculator time, and let's see what we get. So rounding to the nearest one decimal place, I got 26.8 meters per second. Great. Again, multiplying everything on the top, dividing everything at the bottom. So now we get to this third example. How do we convert an area from one unit to an area in another unit? So notice the SQ stands for square. So this is square feet into square yards. Now we know feet into yards. We know that, well, there are 3 feet in 1 yard. So 3 feet is equal to 1 yard. Perfect. But now how do we get square yards? Well, as it turns out, it's exactly what it sounds like. Basically what we're going to do is we're just going to square both sides of the equation. So we're going to square this side and square this side. Notice when you square 1, you just get 1. When you square 3, you get 9. So this will say 9 is equal to 1. Now, of course, the number 9 isn't equal to 1, but with the units, it will make sense. But now this unit won't be feet anymore. It's going to be feet squared because of that exponent property. When you take a product to a power, you're taking the power to each part of the product. So this is 3 squared times feet squared. So if you want to write feet squared like this is actually a synonym for square feet. So square feet is the same as feet squared like that. So that's the same unit, it's just a different way of writing the unit. Similarly, this is going to be square yards, so yards squared. So there's actually 9 square feet in 1 square yard. Perfect. So now we have a new unit conversion here, but now for area. And in fact, you can do the same thing for volume. You would cube both sides of the equation. So that's how you would handle any type of volume or area conversion. You just look at the one that corresponds to the lengths that have those units involved, and then either square or cube both sides depending on what the problem asks you to do, and you're good to go. So great. So with that being said, we know that there is 9 square feet in 1 square yard, so we're going to use our conversion table. So we're going to start with 100 square feet. And we want to convert that into square yards, so I want to get rid of feet squared, and I want to introduce yards squared. And we know 9 square feet are in 1 square yard, so the yard gets a 1, and the feet squared gets a 9. Those cancel out, and then you just divide 100 by 9. So you kind of see that the table method really gives us a kind of more systematic way of flowing through this process. And using our calculator, I got 1.1, so 11.1 square yards are in 100 feet, 100 square feet. Awesome, so that completes the video for our discussion on units and unit conversion. I really hope you enjoyed it, and I hope I set the tone for the rest of the videos coming for this class. I'll see you in the next videos. Thanks for watching. See you then.